So we're now going to walk through a couple of one case study with two parts. The first part of the case study, which is case study ex5, is going to show how to do a bunch of operations on big fractions asynchronously using flux operators and parallel flux operators and the scheduler's parallel thread pool. So we're going to take a look at that example first, and you can find that in the ex5 project in my reactive flux folder in my live lessons GitHub repository. So here we are in the ex5 project. As you can see here, this particular project is going to have a couple of different methods that it's going to be using to test, and those methods are going to be test fraction multiplications and test downloads. And so let's go ahead and first make this thing be happy so it stops being red, which is annoying. And then let's go ahead and take a look at the test fraction multiplications method. So this method is pretty straightforward. It creates an array of big fraction objects. You can see here we've just got a few of them, but we could make more, of course. And we have a little local variable that's a consumer that's going to print the results, indicating what thread they're occurring in. And then we simply use a little flux stream, which is nice and convenient, much less verbose and convoluted than using the flat map concurrency idiom. And you can see here that we take the big fraction array, turn it into an array. So now we have a flux of big fractions. That's a sequential flux, of course. The next thing we do is we convert that flux to a parallel flux using the parallel factor method. We then use the runOn operation that's defined on the parallel flux to say, do all the processing in the parallel thread pool. Then we apply the map operator. Now, this is the map operator on parallel flux, not flux. And so what it's going to do is it's going to take each of those big fractions in the parallel flux, and they'll be multiplied on threads in the parallel thread pool. So that will all take place in parallel. We then go ahead and log these results, which will also take place in parallel. Then we reduce the results. So we take all the results and we reduce them by adding all the results of multiplication together to get us a single mono, which is the results of this. We then print that result, so we know what its value is. And then we return an empty mono, or a mono to void, indicating that we're done. So that's what's going to happen. If we run this program, then you'll see what it does. And we have two parts. We'll just look at the first part here. So you can see here that that's what it does. I'll just let the rest of it run, but we're not going to look at the results from the other part. And you can see what it does is it takes those four numbers, it multiplies them by a big fraction, and it sums the results together. So that's the results of doing this particular set of computations.